Okay, so first of all, good morning to all of you. And how many students are present here whose scholarship form is still pending? How many students are here whose scholarship form is still pending? Kaivalya,
Yes, madam.
you reapplied, no? Narayan Garge, what is your status? Roll number 36. I was given.
आज कंप्लीट करतो मॅडम.
Okay. Send me proof of that scholarship form reapplication. Okay. Then next, who is remaining? Okay, so in yesterday's session we seen one example and I given one example to you to solve at home for the homework. How many of you solved that example? How many of you solved that example? I was given you one example to solve at home. So how many of you solved that example? Okay, if you don't want to respond, leave it. So second question, who will read that question? And tell me the given quantities. What are the given quantities here? Okay, so the question is that determine the size of underground cable if a 11 kV step down transformer is to be connected to 33 kV substation. Okay, we have to find the size of the underground cable if the 11 kV step down transformer is to be connected to 33 kV substation. The distance between the two is 1.5 kilometer and the size of step down transformer is 500 kVA. Okay, so we have to write first given quantities. What are the given quantities first? Okay, so in that, what is mentioned in that question, just listen. One transformer is connected, a step down transformer is connected whose power is 500 kVA, and that transformer is stepping down the voltage level from 33 kV to 11 kV, but you have to consider actual voltage level is 33 kV, not 11 kV, that we are stepping down, but actual voltage level is 33 kV. Then distance between the two is 1.5 kilometer. That means the how much of the length will be of that conductor of cable, 1.5 kilometer. Then next, power is also given in the kVA, 500 kVA. Okay. Okay, power is given 500 kVA. Now what we have to do, we have to find out the size of the conductor. So finding the size of the conductor, for finding the size of the conductor, what we are doing, we are first finding out the current required. That means the how much current flowing through that conductor. So for finding the current, what we are doing, or tell me the procedure of solving this question. Given quantities are also in front of you. You have to tell the procedure. Already last example is solved. If you are not getting, we will solve step by step. Who will tell me the procedure first? Fast. Who will tell? Poonam, Sakshi, Revati. Same procedure we have to follow that we seen in the last example. We have to find the permissible voltage drop, then we have to find the current carrying capacity. Depending on that, we have to select the size of the conductor, then total resistance of that conductor, and we have to find the actual voltage drop, and we have to check is that voltage drop falling within permissible limit or not. If it is falling within permissible limit, then we can use the selected conductor size. Okay, I'm expecting answers from your side. Please give responses.
To find permissible voltage drop, first step.
First, we are finding the permissible voltage drop. So for that, which formula we are implementing?
12.5% of total voltage.
So what is the answer here? How much is the permissible voltage drop?
Four point 125.
125, no? kV.
हाँ.
Okay. So this is the permissible voltage drop. Now we have to find the current carrying capacity. So for that, this is the step one. We can write permissible voltage drop. Then next step two. For that, now tell me the formula. P is equal to
√3 PI.
this 1000 will get cancelled to each other. Then 500 divided by √3 into 33. What is the answer?
8.75.
8.75 or 747. Okay, we have to consider the condition of overload also. So allowing 20% overload. Sorry, it's 8.75 something. This is overload current.
One 1.75.
That means from one phase, how much amount of current will flow? This 8.75 plus 1.75. That means 10.5 ampere. Now for three phases, we have to consider multiply by 3. That means 31.5. Okay, next we have to select the size of the conductor depending upon the current carrying capacity of the conductor. Okay, let's check the table. Okay, now here voltage level is up to 33 kV. That's why we are referring this table for the 33 kV only. If that voltage level is up to 11 kV, we will refer this table. Okay, in the question itself, it is mentioned that substation of 33 kV and we are finding the current flowing through underground cables. That's why this column we have to refer. Okay, so which cable will you refer or prefer? Who will tell me why all are staying silent?
70 mm square.
70 mm square. Be talkative always. We can write at last by referring to above table 3-core aluminum conductor. By referring to above table, okay, this much amount difficulty level questions will not be asked to you in exam, but I'm taking because we can't say anything if that questions will arrive in examination. That's why I'm taking examples. Examples may be asked or may not be asked. Three-core aluminum conductor. By referring above table, three-core aluminum conductor of size 70 mm square. Can be referred or can be selected can be selected to carry given load. Okay, so this is up to this. Now we selected the cable. So next step is we have to consider the resistance of the cable and we have to find the voltage drop. So for finding the voltage resistance of the cable, what we are doing, we are referring a table. Depending upon the size of the conductor, we are selecting the resistance. How much is the resistance? So 70 mm square is the cable size. Now we will see the table for resistance. Okay, this column is for the single core, this is column for the multi core. So we selected the cable of 3 core, that's why we will refer this multi core column. And how much is the size selected of the cable? 70. So for 1 kilometer or per kilometer, for 0.4068, this is the resistance. That means for selected cable, for selected cable size, for selected cable size, resistance is 0.408. Ohm per kilometer. Okay, now we know the distance, total distance, how much it is given, 1.5 kilometers. So the resistance for 1.5 kilometer, resistance for 1.5 kilometer, zero point 408. So last time we divided that distance by 1000, but what why that 1000 we divided by 1000? Because of the distance is given in the meter, here distance is given in the kilometer, that's why we are not dividing this equation by 1000. Okay, in the last question distance is given, distance was given in the meters only, that's why we divided that equation by 1000. So in this question distance is given in the kilometer only, that's why we are not dividing that equation, this equation with 1000. We are just calculating the resistance for 1.5 kilometer. So what is your answer? For this question,
0.612.
0.612. Okay. Ohm. Now we have to check actual voltage drop. So what is the formula? Root 3 into for the voltage drop. So here we will come here. So what is the formula? Root 3 into I into R. So I we are taking per phase 10.5 multiplied by resistance 0.612. So what is the actual voltage drop? I think 11 point something will come.
11.13.
13. Okay. Okay, this voltage drop is falling within permissible limit. Okay, so our permissible limit voltages came in the kilovolt. So this voltage drop is falling within the permissible limit. So we can select the above conductor size. Okay, the actual voltage drop is falling within permissible voltage drop. So we can select 70 mm square 3-core aluminum conductor. Okay, so this is the solution for this numerical. Shall we move towards the next point, or can we solve similar examples like this, or you want more numericals on this?
मॅडम या एक्झाम्पल मध्ये 11 केव्ही पण दिलेला आहे ना.
But the actual voltage level is 33 kV. Are you getting? Suppose here is one substation and here is one step down transformer. Suppose here step down transformer. This is step down transformer consider, and this is substation. This is substation. The distance between these two is 1.5 kilometer. So step down transformer is connected here. Okay. So we have to find the conductor size in between this. So which voltage level will you consider now? Okay, here what is given here? Step down transformer is to be connected to 33 kV substation, and the distance between the two is 1.5 kilometer. That means the distance between at one end substation is connected, and at the other side step down transformer is connected. So the distance between two is 1.5 kilometer, and we have to calculate the conductor size in for this distance. Okay, in between substation and step down transformer. So that's why we are taking the 33 kilovolt. After coming this voltage level may be changed for the next. Okay, are you clear, Supnali? Now?
Hi, yes, madam.
Okay. Okay, now next conductor type, and here one thing you have to take note. We are just solving the examples on the conductor size calculation. Now here we are not deriving no formulas. Okay, so you have to implement that formula for solving the numericals. So derivation will not come here. If you are if you do the derivation also, so it will take time. Derivations I think you seen in the power system or in the other transmission and distribution subject also. So here simple numericals are told, so we will just put that formulas to solve our numericals. Okay, so ACSR conductor. Oh, these conductors are used for the overhead transmission. So ACSR nothing but aluminum conductor, steel reinforced conductor. Okay, the tensile strength of this conductor is very good. That's why these conductors are used for the overhead transmission system. Okay, so here we have to just know the structure of the conductor. Okay, so first of all, this is one cable. Suppose this is one cable. So in that, how much strands are there? So what is the total diameter and what is the strand diameter that we are going to see? Okay, so the total diameter of the cable is this much, from this point to this point. This is the total diameter. Total diameter D. Okay, this is the total diameter. Now, this little are the strands of the conductor. Okay, these are called as the strands, and this much distance is called as the strand diameter. That is denoted by the small d, and this single part, or then this circular part is called as the layers of the conductor. That means this central is called as the zero layer, then first layer, then second layer, third layer, and fourth layer likewise. Okay, these are the layers of the conductor. So this you've seen in the past education, I something in the power system or any other books also, referring books also. So these are the layers. That means this is one layer, this is another layer. Okay, these are the layers, and these are the strands. The circular parts are called as the strands of the conductor. Okay, first take the and this layers can be denoted by X. Layers are denoted by X in the while solving the numericals. And strand diameter, that means the diameter of one strand. Diameter of one strand can be denoted by the small d, and total diameter of the conductor is denoted by the capital D. Okay, are you clear up till this?
मॅडम तुमचा आवाज येत नाही.
Sorry, I don't know when I unmuted myself. कधीपासून आला नाही माझा आवाज?
या slide पासून.
इथून आलं नाही का? आय एम रिअली सॉरी. Okay, so next point is the ACSR conductor. So ACSR conductor is nothing but what the aluminum conductor, steel reinforced conductor. So because of its high tensile strength and greater conductivity, this conductor can be preferred for the overhead uh, transmission. Then we have to see the structure of the conductor. So first of all, we have to know the what is the actual total diameter, strand diameter, etc. What are the layers? So for that reason, I shown you structure of the conductor. So this is the internal structure of the conductor, ACSR conductor. Okay, this is the internal structure of the ACSR conductor. Okay, so the total diameter is nothing but what? The total diameter means what? This is the total diameter of the conductor. So this all strands and all layers will come in the single conductor. Okay, suppose conductor like this will be, so in that conductor the structure will be like this. That means this much amount of the strands will be present in the one conductor, one ACSR conductor. Okay, so this is the total diameter of the conductor. Total diameter of the conductor. So this can be denoted by the capital D. Okay. So next, these are the strands. These are the single strands of the individual cable. That means the minimum size of the cables are used. So in that cables, these are the strands. That means the surface point of the cable or conductor. Okay. And these all strands are insulated by the insulating media. That means the paper insulation or any other type of the paper solid insulation is only used here. So these are the strands, and the strands diameter can be denoted by strand diameter. The strand diameter can be denoted by small d. Then next, we have to see what are the layers of the cable. That means the what are the layers. So this central part is one layer. That means the we can number it by 0. Then next, these three, sorry, these are the 5 strands. So these 5 strands comes under the first layer, then second layer, then next layer. So these are the layers of the conductor. So this is this structure is for the 4 layers of the conductor. Okay. Okay, now we have to see some simple examples, numericals based on this, and to find the diameter of the wire. That means suppose if you have to find the diameter of the wire, if remaining quantities are given, then which formula we have to use. So just to take the note or screenshot of this formula. These derivations we are not going to see. The derivations are always, I think, you seen in the power system or transmission and distribution subject. So here we have to just implement all the formulas for solving the numericals. Here we are not going to derive the formulas. Okay, if you have to find the total diameter of the wire, then which formula we have to use? 2x minus 1 multiplied by small d. So capital D means what? total diameter of the conductor, ACSR conductor. X means what? The total number of the layers that we seen, like that layers. And this is the strand diameter. That means this diameter. Suppose there are multiple numbers of the strands, and diameter of the single strand is called as the strand diameter. Okay, now we have to implement these formulas for solving the numericals. Okay, next question is, the wire has strand diameter of 5 mm. Strand diameter means what? Capital D or small d? Small d. Okay, then number of layers, that means X is equal to 3. Then what we have to find? We have to find the total diameter of the wire. So first of all, write all the given quantities given. Okay, okay, this first of all, write the all given quantities. So strand diameter is nothing but what? Small d. Small d is 5 mm. Then next, what is given? Number of the layers. Number of the layers can be denoted by the X. X is equal to 3. Then we have to find the total diameter of the wire. So for finding the total diameter, capital D, we have to use the above formula. That means the 2x minus 1 multiplied by D. So just to put the values given quantities in the question. And tell me the answer. Is this answer correct or not? Okay. Similar like that, to find the number of strands. Now we implemented the formula for finding the number of the diameter of the conductor. Now if you are to find the number of strands required in a conductor, that means if the layers are given, then we can find the number of strands required. That means how much the circular strands are required, like that we can calculate it by the formula. So the formula itself is given in the here. So all of you note the formulas. Number of strands, if you have to find the number of strands in a wire, then you can use this formula 3x square plus 3x plus 1. So here what is given, number of layers are given. That is denoted by the x. Now we have to find the number of strands in a wire or conductor. Okay, so for finding the number of strands, which formula we have to use? 3x square plus 3x plus 1. So just to put the value of x, what is the answer? Four square suppose this is one conductor, this is the central part, then again this number of the strands are used, then next layers. So as like that, 4 layers are required to actual shape is not coming because I'm drawing it by mouse. Okay, like that 4 layers we need to draw here. And how much strands will come here? That means this is single strand. So like that, how much strand will come here? So put your answer. So someone do the calculation. What is your answer here?
61.
61. Okay. So 61 strands will be required to form the 4 layers of the conductor. Okay. Okay, we will stop here for today. Thank you for joining the session.